Hello everyone, I'm Anika from 7MB, and today I will be presenting my science project, Rutherford's experiment. Ernest Rutherford was a New Zealand-born British physicist who is famously known for splitting the atom. His work on the gold foil experiment contributed greatly to the model of the atom and helped develop the standard model of the atom to what we now use today. Before Rutherford's experiment, the most popular model of the atom was the plum pudding model, developed in 1904 by J.J. Thomson. In his model, the electrons were thought to be embedded in a uniform positive charge, like blueberries stuck into a muffin. To rephrase this, the atom was believed to consist of a positive material pudding with negative plums distributed throughout, as you can see. Without Rutherford's contributions, we would still be using this outdated and incorrect depiction of the structure of an atom. Now, what exactly did Rutherford do? In 1911, Ernest Rutherford, along with Heinz Geiger and Ernest Marsden, carried out the famous gold foil experiment. I will be using my model to show you his experiment. As we can see here, he used a radioactive substance as a source of alpha particles, locked in a lead container with a very small slit. Alpha particles are helium ions with a charge of +2 that are emitted due to radioactive decay. The lead container ensures that the alpha particles only come out through a small opening and travel in a straight line. You will find out the purpose of why we use alpha particles soon. Here we have an extremely thin piece of gold foil on which the alpha particles will bombard. Rutherford chose gold foil because of its elevated malleability, which makes it possible to have just a few layers of atoms to make the experiment as convenient as possible. Finally, what is this circular band with a gap? This is a detector, specifically a fluorescent screen, which will help us detect where and whenever the alpha particles hit it. This way we can also trace how much they deflect on hitting the atoms. Essentially, if the plum pudding model were accurate, the alpha particles would, go straight through, pierce right through with little to no deflection, because alpha particles have greater mass and energy compared to the positive sphere of atoms, according to J.J. Thomson. Now, when Rutherford conducted his experiment, he expected the alpha particles to pass right through the atoms and hit the detector straight and directly, because the mass of alpha particles is heavier than the mass of positive charges, as we discussed. Only a minute deviation would be acceptable due to the repulsion of charges, as the positive sphere of the gold foil would repel the positive charge of the alpha particles. But Rutherford was astonished to get unexpected results. Are you ready to find out? I'll show you using the model. Let's see if you can figure it out. So I'll be taking my radioactive source, aka a laser, outside of the lead container as it already has a small slit for the laser to come out of. Here the alpha particles have hit the gold foil, as you can see here. So some of it would go straight through, right behind the gold foil like this, but a sizable amount are also deflected by large angles in this range. Right, and shockingly, some particles have even rebounded in regions like here and here. It's quite mind-blowing. So Rutherford found that most fast-moving alpha particles pass straight through the foil and hit the detector. However, some particles are deflected by large angles, and some, lastly, to his bewilderment, have also rebounded. Specifically, 1 in 20,000 particles have changed their direction of motion by more than 90 degrees. These 3 observations made Rutherford think that the plum pudding model wasn't accurate, and I agree. So, based on his conclusions, he put forward a new hypothesis explaining the structure of atoms. The 3 conclusions he made were: there is a positively charged mass concentrated at the center of an atom. This volume at the center is called the nucleus. And, fun fact, that's Latin for little nut. The electrons revolve around the nucleus in circular paths, like planets revolve around the sun. And finally, the size of the nucleus is extremely small compared to the size of the atom. Although his hypothesis has since had some flaws, and we have made new models for atoms since then, his work is highly commendable and has laid out the foundation for other scientists to hypothesize more accurate models of atoms. So thank you, Rutherford, and thank you for watching.